Imagine, for a moment, running your fingers through the soft, sun-warmed sand at the edge of the ocean. The grains slip past your skin, tiny, rough, and unremarkable. Now, picture holding a flawless glass of water in your hand, sunlight sparkling through it, or tapping on the gleaming surface of your smartphone. It's hard to believe that these two worlds, so gritty and so pristine, are linked by one of the most extraordinary transformations known to humankind. The story of glass is the story of how the Earth's most basic materials are reborn as objects of clarity, strength, and utility. The journey begins with silica sand, an ingredient so vital that its quality can determine the fate of the final product. Not all sand is created equal. The sand destined for glass must be almost pure quartz, free from iron that would give an unwanted green tint, and without organic matter that could create bubbles or weak spots. For centuries, glassmakers have sought out deposits of this rare sand, sometimes shipping it across continents to ensure the clearest, strongest glass. But sand alone cannot become glass. To unlock its potential, it must be combined with other ingredients, soda ash and limestone. Soda ash, or sodium carbonate, is a kind of chemical key. It lowers the melting point of silica, making the process more efficient and less energy-intensive. Limestone, on the other hand, adds stability, helping the glass resist weathering and chemical attack. In a modern glass factory, these raw materials are delivered by the ton, stored in towering silos, and measured with the precision of an apothecary. Massive mixers blend them until every handful is identical, ensuring that what comes next is as uniform as possible. The heart of the process is the furnace, a glowing industrial inferno that dwarfs anything you might find in a blacksmith's shop. Here, the carefully measured blend of sand, soda ash, and limestone is fed into a cauldron of fire. Temperatures soar above 1,700 degrees, hot enough to turn the gritty mixture into a churning, molten river. It's a sight that's both ancient and futuristic, reminiscent of volcanoes and stars. In this state, the mixture is no longer sand, but not yet glass, an orange, viscous liquid, alive with energy. Now comes a feat of engineering that seems almost magical, the float glass method. Before its invention, glassmaking was limited by the difficulty of creating flat, even sheets. But in the 1950s, scientists discovered that if you pour molten glass onto a perfectly smooth surface of molten tin, the glass spreads out, flattening itself by the simple forces of gravity and surface tension. The two liquids don't mix. Instead, the glass glides atop the tin like a skater on ice, forming a ribbon of breathtaking smoothness. This process runs continuously, day and night, transforming rivers of glowing glass into endless panes. But glass is a temperamental material. Cool it too quickly, and it will shatter from internal stresses. Cool it too slowly, and it may warp or become brittle. That's why the next stage is the layer, a long, gently heated tunnel where the glass ribbon is slowly cooled and annealed. Here, over the length of a football field, the temperature drops from searing heat to comfortable room temperature. It's a slow dance with physics, allowing the molecules to settle into a stable, stress-free structure. Once cooled, the continuous sheet of glass is ready to be shaped. Robotic arms, guided by lasers and intricate sensors, zip along the surface. They score the glass with perfect accuracy, snapping it into sheets of any size required. Each one is immediately inspected, not by human eyes, but by advanced cameras and artificial intelligence. These systems scan for the tiniest flaws, a bubble, a scratch, a hint of distortion that could compromise the glass's strength or clarity. Any imperfection is cause for recycling. The flawed glass is shattered, melted again, and given another chance. Depending on its intended use, the glass might not be finished yet. If it's going to become a window for a skyscraper, it may be tempered. This involves reheating the glass and then cooling it rapidly with blasts of air, locking in extra strength. If it's destined for a car windshield, it will be laminated. 2 sheets of glass are fused with a layer of clear plastic. This means that if the glass ever breaks, the plastic holds it together, protecting the people inside. Finally, the finished glass is carefully packaged. Sheets taller than a person are slid into wooden crates, labeled with barcodes and tracking information. Some will travel by truck, some by ship, crossing oceans to reach their destination. In less than a week, sand that once lay buried beneath the earth may be transformed into the gleaming windows of a new building, a mirror in someone's home, or the screen of a device that connects people across the globe. But the journey of glass doesn't end at the factory. Its story is woven into every corner of our lives. Glass lets us gaze at the stars through telescopes, study the tiniest cells with microscopes, and see the world safely from behind the windscreen of a car. It brings natural light into our homes, protects us from the elements, and forms the foundation of the digital age. From the first crude beads made by ancient humans to the ultra-thin, high-strength glass of today's technology, this humble material has shaped civilization in ways we rarely stop to consider. So, the next time you press your hand to a cold window pane or peer at your reflection in a mirror, take a moment to remember the journey that began with grains of sand. Behind every sheet of glass is a story of heat and transformation, of human ingenuity and the raw power of nature. It is a testament to what we can achieve when we look at the world not just for what it is, but for what it could become. Glass, born from burning sand, is a transparent miracle, an everyday wonder that connects us to both our past and our future.